large. It consists of a bunch of people that work at Galois, as well as some students that I worked with in the past when I was a professor in Europe. And Kathleen's the one who convinced me to do it, in some sense. Or, yeah, in the end. The actual performers on the contest are about 5 of us. Actually, did stuff like writing code or writing funny stories. And we have to thank sort of our senior folks at Galois that gave me enough rope to do this, because that's an unusual thing to do in a company, and that's Leah Daniels and Rob Wilpank, our CEO. A bit of history, I actually got asked to run the contest a couple of years before, and that was when I was in Europe. And I ran out of time to do it because I decided to change jobs. And basically the changing of jobs happened at the same time the contest prep was going on. So we said, why don't you go ahead and let Oxford run it, and we'll try to do it next year. The colleagues I recruited at the time were David Christensen. Where's David? Stand up and wave, David. Well, David's at the back. He helped out with this too. And Hannes Menner, who's not here, I suppose. Hannes, you here? Nah. So then we went back to the USA, and I said, we'll try to do it again, but I know how hard that's going to be to convince people to do it at a company. Because, of course, if they let you do it in the company, you're doing it on company time, so to speak. So Galois is a weird organization because it's not hierarchical. It's a peer-to-peer organization. You build guarantee relationships with your colleagues, and that's how you get work, find work, win proposals, etc. And so I had to basically get there and convince them to do it. And most of the folks there love to program, but they also love to have billable hours. So there's a delicate balance here. I have no power, but eventually I did, influence folks, and I got the okay to run it in, August 2014. We started having meetings about it in February. And in early to mid 2015, we basically sketched out story ideas and some programming challenges and the like. Now, to do a good contest, we thought we really had to understand the past well. Some of us had participated in various contests in the past. And Dan and I have run numerous contests, like for the ACM, and I've run one of the software verification programming contests in the past. But we hadn't seen all the history of ICFP contests. So we went back and read over most of those, talked to people about their experiences in participating, and tried to build from that sort of a working model of what would be fun and interesting and challenging. So we set out some basic requirements from that. Basically, it said, well, we want to take advantage of our expertise at Galois. We want a contest that has a backstory, so it's fun and can create a fictional world in which we can all play during the contest. And we wanted a challenge that was hard and interesting and connected to the story, but didn't require a PhD in computer science. The original challenge we came up with, I was very enthusiastic about. It was mainly crafted by David in the back and Daniel Wagner, who works at Galois, and was focused on programming languages and verification. And the idea was that we needed to come up with a very devious, kind of horrific, one that might drive you insane, hint, hint, programming language that folks would have to write interpreters or compilers for, and then you would have to write essentially metaprogramming on top of it. That language was basically a lambda calculus-based language, but not like any lambda calculus you've ever seen. If you think about sort of the sigils and strangeness of like Charles Strauss's work meets Hellraiser, it was that kind of thing. We might finish writing it up and release it just for fun. It was completely horrible. It made you approach the problem in very novel ways, and it had very interesting visualization angles. Though if you visualize what you're programming, you might go insane. But the actual contest that we ended up using, because we found that one wasn't too much fun, I lost all my hair after all, Yavo will describe in a moment. Along with the contest itself was a storyline that we came up with, which was basically in the venue of a alternative reality sort of thing, along the lines of the work of Lovecraft, Piercy, Richter, and Strauss. I actually exchanged several emails with Charles Strauss in the crafting of this particular story. He's an enthusiastic supporter now of ICFP. And the premise is that humankind can accidentally or purposefully get the attention of great, horrific, scary old ones. If you've ever read Lovecraft or see any stories based upon his work, that is the venue we're working in. And you do that via computational means. For example, you might specify a really complicated dependent type, and that is the name of a demon. And suddenly a gate opens up next to you and he swallows you whole. And all that's left is an empty chair and a Haskell program that just compiled. So the Avengers of the world that defend us from this horrific reality are Turing Award winners. They are the strike team. You know, it's like Ron Rivest is the Hulk, and you know, Tony Hoare is Iron Man, or something like that. And they are the ones defending the world for us on behalf of some mysterious other government organization. And the problem is, of course, you only get a small number of Turing Award winners every year. And so we just don't have enough scale to defend this growing threat. And so the ICFP contest is, in fact, a way to find new Avengers to join this team. The main characters in the story, which I encourage you to read, are Ron Rivest, Tony Hoare, Barb, Leslie, Robin, Don, John, and Grigori. I know all of them except for Grigori. He's a little reclusive. Also mentioned are Burbakai, Bakru Banzai, my hero, John, Alistair, John, and John. You'll understand all the Johns if you've ever watched Bakru Banzai. Thus far, Ron and Barbara have personally congratulated all contest winners. I expect several more people will be doing so soon. Yavor will now describe the problem.
All right. Well, so, as Joe was saying, I kind of joined the project later on. So with 3 weeks before the program, I was exposed to this horrific programming language. I scratched my head, and I agreed. It was difficult to come up with any idea of how you might solve the problem. So we had a little bit of time to come up with a new problem. So we decided to get the contestants to play Tetris instead. Now, why did we do that? Tetris is a kind of a fairly simple game, and in fact, we use it at interviews at Galois. So if you ever interview at Galois, you might want to practice your Tetris skills. We sit together and program Tetris together. So I was pretty familiar with the problem, and I knew that you can quickly come up with something working with the rules. I also thought, well, it's a good problem because everybody knows the rules for Tetris. Now, of course, a lot of people have already implemented Tetris, so we wanted to add some twists. So the first twist we did is that we changed the geometry. Okay, so normal Tetris on the left uses squares, a square grid. We use the hexagonal grid instead. So every dot has 6 neighbors instead of the usual 4. Okay, we also changed the pieces. So in normal Tetris, there are these standard pieces. You always play with the same pieces. And it was actually really fun to find out that mathematicians out there study Tetris. We learned that apparently solving Tetris is an NP-complete problem, so we were sure that it's probably a fairly difficult thing to do. In our problem, the pieces are not actually fixed. So as part of the problem, you're told what pieces you're going to have. And so some of them are kind of standard translations of the pieces to a hexagonal grid. But some of them, like this alien or Cthulhu at the bottom, can get exotic. Okay. Another thing we did, and you understand on the next slide why we did that, in Tetris, normally you press a key and the piece rotates, you press another key, the piece moves down. We actually have a lot of different keys that do the same thing. So for example, A, G, H, J, and I all were moved to southwest, right? So in a hexagonal grid you have 2 downs, the down left and down right. So all of these were the same command. And that was the case for every command. It had a sequence of keys that worked, a set of keys that worked for it. Okay? And the reason we did that is that there were power phrases. Okay? So some sequences of key presses gave you a bonus. So, okay, so it wasn't enough to just control the piece to where you want it, but if you press the right keys and you spelled a special word, such as I, or...
You gotta say it right.
I? Or...
Relay! I'm a Lovecraft geek.
Yeah, so I knew nothing about Lovecraft coming into that, but it's been very fun. Would give you a lot of bonus points. So this kind of added an extra complexity to the problem. Okay, and to give you an idea of what it looked like, so here is a level, and there is a game playing. So this is one of the solutions of the contestants. You see, the initial board does not start empty. Like in Tetris, you do delete lines. And then you have 2 different scores there. The one is for when you use these power phrases, and one when you don't use the power phrases. And some of the levels were small like that, and some were quite a bit bigger. So we had a little bit of fun. You might recognize these pieces in the city of Vancouver here. But so anyway, this was a fun level because it was quite big, and so you had a lot of options of what to do.
Virtually, it's all power phrases at the top.
Yes, so you can see the little counter up there, that it's not showing is when there is a power phrase. So whoever did that is racking a lot of points with the power phrases.
Oh, boy.
And did you see, like, sometimes you can rotate things across lines as well? You could do all kinds of clever things.
Through rotation, you can do marvelous things.
Okay, and I think that's all I've got to say. Okay, so how we structured the contest. So the actual contest was run in two phases. This was the evaluation. So first there was the qualifiers, and this, as usual, this was 3 days, Friday, Saturday, and Sunday. And we provided 25 sample problems. So there was an initial board and a collection of pieces plus some random seeds, and you were told play for 100 pieces or something like that. And so the idea was that basically during the contest, teams would just submit sequences of key presses. So they would say, something like what I showed on the previous slide. We score those sequences. We don't care how they came about. If you wanted, you could play manually. If you wanted, you could write a program. That, of course, helps with these weird rules. And then the idea was that the best teams will qualify to the finals, which happened after the contest when we actually got the submitted programs, we built them, and ran them on a bunch more programs. So the finals. So out of all the submitted, I think there were, we will see a whole bunch of statistics in a moment, but there were about 150 teams or something. We submitted the top 10, and we were a little bit, so how did you find these power phrases? There were hints that Joe and Dan were hinting on Twitter, and they were kind of slowly being revealed. But I was really worried that teams won't be able to find them, but almost a lot of teams found almost all of them. At one point, they were actually submitting Wikipedia pages to see if they might get, bonus points for power phrases. It was quite impressive. So we scored the programs in two ways, once with the power phrases and once without. So the one was just how good you're at playing Tetris, essentially, and the other one is how good you're at playing Tetris and with this additional difficulty. And so we basically ranked the top 10 in both kind of categories, and it turned out that there were 4 teams that qualified in both of them. They were in the top 10, so they qualified, and then the remaining top 3 teams of each category qualified. So we had overall 10 teams. And so we tested them first we tested them on the original problems we gave them to make sure that they can actually solve them, right? And they didn't just cheat somehow. And then we also made a whole bunch of other problems which were usually specifically crafted to test some aspect, to see, I wonder how many pieces in the future do they look, and things like that. And furthermore, we also messed around with the power phrases, so we scored each 4 different ways, one without power phrases, one with the power phrases we gave them, and they were supposed to support other power phrases too, so we picked some really difficult ones. That was about it. So Dan would now tell you a bit about the statistics of what actually happened.
Right, so we had almost 800 individual participants register, and of those, about 250 actually submitted solutions to one or more puzzle. 315 teams, 217 of those submitted solutions to one or more puzzle. About 6,000 solutions per team were submitted on average. And at the end, 140 teams actually submitted their programs, and 78 teams submitted for the Lightning division. So overall, we had 1.25 million solutions submitted, about 126,000 in the Lightning round alone, 775 megabytes of command sequences, and of those, 450 of them were submitted by one team that was really, really good at gaming the scoring program, but didn't actually end up making it into the finals. And the programs that were submitted at the end, 4.3 gigabytes of source code. So a lot of participation.
Mechanical Turk, right there in front of you.
These are just some plots of how many submissions per hour throughout the life of the contest. And so you can see there was a pretty high rate of activity throughout with some spikes. This last hour, 72, is actually really just the 5 minutes between 5 a.m. on Monday when the contest ended and 5:05 a.m. when I turned the contest server off. So there was a lot of activity in those last few minutes. Many bytes submitted each hour as well, except for some reason, this hour was...
Your pointer.
Oh, my pointer isn't showing up. That's annoying. Well, hour 6 for some reason. Very little activity. Don't know why.
First coffee.
Yeah, perhaps. This is the growth of the number of submissions over time and the growth of the number of bytes over time, and really big submissions seem to come in at the end. So, lots and lots of data. And so one of the lessons that we took away from this is basing the contest infrastructure in the cloud turned out to be a really good idea. Because, as Yavor mentioned, people were cutting and pasting Wikipedia pages and doing all sorts of other crazy things to try to find power phrases, and Galois's poor network would have just been completely overwhelmed by this. Another thing that we learned was that we probably should have done a little bit more playtesting in advance, just because some of the problems that we gave turned out to be very similar to some of the other problems that we gave in terms of what was required to solve them, and it would have been a little bit better had we messed with it a bit more in advance. And then another lesson is that if a, let's say, feature is available in the contest scoring system or submission system, some teams will actually use it. So for example, near the beginning, we woke up in the morning after the first night to find that one team had scored 8 million points on one of the problems, and it turned out that this was a bug in the scoring system, and we had to go and fix it and various other things. And another interesting thing that happened near the end of the contest was that the submission system actually leaked enough information to people who submitted and then had their responses evaluated that teams were able to figure out which power phrases they had learned and compare those to which power phrases other teams had learned without revealing what the phrases were. Like, I learned power phrase number 17.
Yeah.
I see you know phrase number 15. Maybe we should trade.
All this was live
Right.
on IRC.
So there was this black market being set up on IRC during the
And
contest.
everyone was speaking in the vernacular of the contest. So it wasn't it was power phrases and they wanted to save the world.
Right. and I mean, at one point, one of the teams asked me if I could actually serve as an escrow agent for a power phrase exchange, which I declined to do on behalf of my agency because they would not have approved. So, with that, I think it's time to start introducing the winners. Joe, would you like?
Sure. Well, I got a mic here.
Oh, you have a mic. Great.
So, it's time to introduce the winners. And so many of the winners are from far, far overseas and require visas that take months to get to be here. So several of them aren't here. One team is here. Third place is Team Bycode. I think we should all clap for Team Bycode. Therefore, we officially declare that C++11 is not too shabby. Team Bycode couldn't be here today, but sent a very tiny video to introduce themselves and to explain how they tackled the contest.
Hello everyone, my name is Roman Dorichenko, I am from Belarus. I am representing Team Bycode at the ICFP 2015. Other members of our team were Alexei Ropan and Boris Chuprin. I will tell you in brief about some details of our solution. Main powers of our solution are quite obvious. There is some heuristic function to estimate fitness of some unit placement. For each unit in the sequence, find the position with the biggest value of the fitness function, and for the found position, find the path which leads the unit to that position using as many power phrases as possible. This process was repeated for different heuristic functions which considered different factors such as lines removed, gaps between placed units and other locked cells, amount of locked cells near unit, etc. Always different coefficients. There was a dynamic programming solution to deal with levels where all units were like straight lines 1 times x. There also was some kind of genetic solution which considered several board states at the time after some number of turns and selected best states again after trying best possible moves. So that's it, and this was the first time I participated in ICFPC. The task was kind of quite standard optimization problem, but I enjoyed it a lot. I want to thank all organizers for clear statement and nice scoreboard. Contest was prepared very well in my opinion, and I'll be waiting for the next year contest. I wish all of you to have an amazing day, and thank you for attention.
What a thankful audience. Yes. So congratulations to Team Bytecode. The second place team is Team Masturbate. So therefore, we officially declare that C++ and Python and JavaScript are fine programming tools for many applications. Team Masturbate could not be here, but they sent us a slide on behalf of their solution. So there's the team. Basically, they run various AIs in parallel, using multiple techniques concurrently and synthesize those results. Then a post-processor actually analyzes their solutions that they came up with playing traditional Tetris and reverse engineers power phrases into that. A scheduler runs the AIs, and the post-processor honors time limits because we indicated how long they could run, and therefore just picks the best solution when the time runs out. The winner of the Lightning Division is Team Frictionless Bananas. Yes? So therefore, we officially declare that C++ is a very suitable for rapid prototyping language. Team Frictionless Bananas is here and would like to say a few words.
Hello. My teammate unfortunately had to leave early today, but so I'll be speaking just briefly about our submission. So, yeah. So as you heard, we use C++, as they say in Canada. Sorry. So we decided to basically split the task, the two parts of the task, into two separate implementations. So we had a Tetris solver that decides where each piece will end up, and a phrase solver that then decides how to get it there while spelling these various power phrases. I will only be describing the Tetris solver since the power phrases did not contribute to the lightning round scoring. So it's really pretty simple. We processed each piece one at a time in order, did not do any look ahead. We just find every possible location for the piece, score it according to some heuristics, and choose the best of those locations. One note is that if there were multiple equally good locations according to the heuristics, we would choose randomly, and so that gave us an opportunity, if we had a lot of CPU time available, to run with multiple seeds to the random number generator and get various different solutions, which would just by chance sometimes be better than others. And so the heuristics were, we had two main strategies. One was to try to play the pieces as low as possible on the board to fill in holes and such, and we had a couple of different variants of that with either maximizing the y-coordinate of the lowest cell of the piece or the average y-coordinate of all the cells of the piece. And then the other strategy was to try to play pieces in whatever rows already have the most filled cells in them, which was designed for these boards where the initial board configuration already had a lot of stuff in it, and so by leveraging those existing cells you could complete rows more quickly. And so with both of these main strategies, there could sometimes be ties between multiple positions. And so as a tiebreaker, we would examine all of the neighbor cells of the piece and try to maximize the number of those neighbor cells that are filled by other things that are already present in the board. So that sort of gave us a nice interlocking behavior, like a jigsaw puzzle, where the pieces would fit in very nicely with what was already there. So that in particular worked fairly well. That's pretty much it.
Great. Thanks, Jeremy. We'll talk later. The first place team in the contest is Team Unagi. You might recognize this team. So therefore, we officially declare that C++, Java, C#, PHP, Ruby, and Haskell are programmers' tools of choice for discriminating hackers. Team Unagi used more languages and frameworks and tools than pretty much anything else we looked at, and they gave a little presentation as well. Team Unagi you may have heard of before. They have participated in the past. They're a team from Japan. They took second place in 11, first place in 13, and second place in 14. Basically, their system had a front end, as you can see, talking to solvers of various ilks. Yeah, I don't want to talk about it. And they solved boards with two solvers in parallel and evaluates the results. The two solvers that they wrote have strange names and have some basic strategies and phrase embedding and sort of are tuned for two different dimensions of problem solving. And then they also did a parallel evaluation system with an internal scoreboard so that they could compare various results they came up with, and then try to write a tool to actually tease the server and figure out what sort of phrases existed. This is particularly useful for the teams who don't have English as a first, second, or third language. So that is Team Unagi. Finally, of course, we have the Judges' Prize. The Judges' Prize goes to Team Wild Bashcourt Mages. So, Team Wild Bashcourt Mages is a very amusing team. They really got into the spirit of the contest. We really appreciated interacting with them. So we officially declare them an extremely cool bunch of hackers. Their submission was among the top 10 selected. So they did quite well in the contest as well. They actually finished in 5th place, so they're that team that always goes shucks. But they impressed us really with their enthusiasm with the artifacts that they submitted and their interactions with us. And they have sent to us a demo to celebrate their particular participation. Now I'll preface this with a couple of things. Firstly, these guys are from Bashkortostan. How many of you have heard of Bashkortostan? It's a real country, or pseudo-country. We thought it was fictional for, 30 minutes? As we were evaluating this. Going to Wikipedia and other resources, etc. It's a little fiefdom inside of Russia with a president who's put in place by Putin, and it's kind of like Christiania in Copenhagen. It's very strange. And so these guys were hardcore but strange and mysterious, which I like because I'm a bonsai fan. The second thing I'll say is that their talents range in many dimensions, including the demo scene in Europe. And so what they've sent it to us is not a presentation. It is a demo scene demo, which they wrote in the last, how many hours, Dan? In the last 24 hours, they wrote this for us. One of them was in the hospital at the time or something. It was a crazy story. Yeah, an appendectomy. I guess he was going, ouch, as he programmed. And then the third thing I'll say is that the thing that particularly impressed us about them is their enthusiasm. And one facet of that enthusiasm is they sent us a fictional version of the Bashkortostan national anthem sung to the fictional version of the Kazakhstan national anthem from Borat. And they promised, if they were to win, they would sing it for us. I give you the Wild Bashcourt Mages.
Kurdistan, best country in the world. All other countries are run by little girls. Kurdistan dominates for their programmers. Other countries have inferior programmers. Kurdistan number one in technology, computer science and algebraic topology. Alright, we have prospering world to be born. Recently our disk is almost 20 years old. Kurdistan, you are a very nice place. From Samsung Bay to any use of Ufa. Kurdistan, friend of all excluding Tatarstan. They speak Tatar language instead of Kazakhstan. Kurdistan industry, best in world. We invented honey and crude oil. Kurdistan scientists, greatest in the region, except of course for being unknown. Kurdistan is a very nice place. We protect it with awesome workmanship. From the eastern country, domination by the glorious nation of Kurdistan.
So we will be posting all artifacts relevant to the contrast publicly. We have to move them from one GitHub repo to another. And the other thing we'll say is we are wearing interesting t-shirts. We encourage you to look closely at them. They have Easter eggs in them. And we're probably going to throw them online if you want to buy one yourself. That's it. Thanks very much.
Thank you very much. Right.